everybody. Welcome to Rocket Lasso Live. This is episode 11 of season 7. How is everybody doing? I hope you're doing well. Let's see how this goes. We're going to have to make sure we end the stream at the proper time. I'm doing some traveling this evening. Looking forward to that. So start getting those questions together here in the chat. I see Tobias has a question going. We got one over here on YouTube as well. Rune's asking a simple question, but it's just a question of, is it possible to get the redshift toon shader contour rendered with a spline? I don't know. I don't think so. But I haven't done a lot of the redshift toon stuff. That's more EJ's area of expertise, so he would probably know one way or the other. Maybe we can bug him about that. Maybe get him on the stream as well. And let's see what Tobias has got linked here. I'm going to click on that, and I'll bring it over in just a moment. Let's see. Is this the original? It's in Spanish. Well, anyway, let's jump on over. And this is boom. So here we've got, a relatively simple mechanical rig here where there are two gears spinning. I guess it wouldn't even be gears, but these two different rotations are happening, and we've got this mechanical arm, and then you get the end result based on where the pen is going. And in theory, if these are on some sort of like even repeating number, eventually it's going to start looping. And yeah, it looks like it did just get to the looping point, and now it's just going over those lines again. So pretty interesting shape. The variables here, and this is from Geometrias. Agrada. So yeah, I think we can make something like this. It's kind of, in a lot of ways, this is similar to a what do you call those things? The old spirographs. It's doing some similar things, and some of these motions where it like dips way down. Yeah, some of that stuff is pretty cool. Let's go over to our laptop here. And here we are in 2025.3. And we're going to be doing some mechanical rigging here. Now, in theory, we could do it with math. In theory, could we do it? Is it possible that we could do it using just regular rigging techniques? It is possible. Actually, I do think it would be right. It would be available in regular rigging techniques, but we could try doing it with proper simulation. If somebody, it's going to take too long for people to respond, but I was going to say, like, should we tackle it with simulation or try and tackle it on like raw rigging? Actually, I will wait a moment to see if the chat responds one way or the other. And while I'm waiting, I'll start getting some of the basic shapes going. Actually, we don't even need that. Let's use the gear. We don't use the gear very often. The C4D cogwheel. And let's lay that flat on the ground. And we got a lot of options here. We can get rid of that inlay. And we even got these teeth. I think I want to do some, not undercut. Is it inlay? Yeah, inlay spokes. Yeah, these inlay spokes can look pretty cool. Arches, I think, actually. Oh, no, it's the holes I want. So let's get some spokes going. And yeah, we can bevel those, which I think always looks pretty cool. And yeah, so tons and tons of control over exactly how these look. So that looks kind of cool. And in the teeth, we can even say that there are no teeth. Oh, I guess we want a flat. So yeah, there we go. We just get a circle. So you can see we can make some, like, even though this is supposed to be the cogwheel, you can make all sorts of really cool shapes like this. Dean, well, you're saying not rigging, which means probably 3D or simulated, is what I'm guessing there. Now, if we are going to do simulated, the scale of the scene is relevant. So now I might not want to go too super duper tiny, but if we're trying to be realistic and go pretty dang tiny, I might end up making the gear something like that. Oh, Not rigging, not simulated. Okay, so not simulated. Okay, we've got one vote for not simulated. And yeah, I see other questions popping in. Yeah, let's do that. And how do I want to do this? So this is just for reference. Now, I might even just keep these splines just for simplicity. And I don't even know if this is going to be possible without simulating, but let's see if we can. So let's start layering up a few different things here. Let's lay this down on the ground. And I'm going to aim it on Z. Typically, Z is forward. So that will be this longer arm, something kind of like that. And if we want to make it look kind of nice, we can add some rounding. Okay, so now here's the idea. Let's change this to be 6. Maybe increase the gap a little bit there. Which one of those is? Woo. Sensitive. Yeah, something like that. Okay, cool. So we need essentially a pivot point here. So do we make it visual? I might just make it a null right now. So here is the rectangle in this null. And let's get a scale here. Let's say this is 30 centimeters long. And then I will scoot this up 15 centimeters. And now we can just eyeball this. Although I'm holding shift, so it's jumping 5 seemed to do a pretty good number up to there. And yeah, so now we are pivoting not from that round spot there, which maybe it would be good to do. So scooting that even one further. So if I turn on this axis and then actually, no, we'd still have to yank this out. I could maybe jump this up to 6, which is probably, yeah, 6 is pretty good. So we'll do that. So that's going to be one of our first pivots. Now that's aiming straight up. Let's see, how do I want to do this? Because we're going to be fairly meticulous with this. Let's jump, turn off axis. Very dangerous to have that on if you don't intend to. Do we want to worry about any vertical dimension? Maybe not. So let's drop this as a child of the cogwheel. And we're going to make that, eventually, we're going to make that spin. So I want this to aim always in a particular direction. This is we're doing some safety stuff here. So let's make a null. And actually, let's make a copy of the original null. And we're going to call this one up vector. And we'll just say arm left pivot. And this will be the arm left pivot up vector. Now, we take this copy of this null, and I'm going to move it straight up into the air. I'll move it up 10. It doesn't matter how far you go, but now that's up in the air. So now we can right-click on this pivot and say that you are going to get a rigging and tell it to get a constraint tag. And then we say we want this to aim, and this is what it has to aim at. It has to aim at this thing. So we're going to say you have to aim on your y plus axis at this up vector pivot, no matter what. Now, nothing should change. We built it cleanly. But if I were to take this and kind of wiggle it, you can see that that's going to change. It's now aiming at that no matter what. Now, whenever it can, I want this to aim at something else. So, oh, is this going to work? And then I got to make sure, let me pull out the reference so I can take a peek at it. Okay, we might dead end here, but let's experiment. So now we want to aim at something. Now I'm just going to make something for it to roughly aim at. So let's just make a star shape. Lay that flat down on the ground, T for scale. Okay, so this star, just so we can visually see it, that's going to be what we're aiming at. So I will say in this constraint tag that's now going to get an up vector, and the up vector it's going to be on the axis of y plus, because that's what we already had our aim at. And now I'm going to say my z plus, the z plus, we want to have it aim at the star shape. So now you see it's pivoting over there. Now what's cool about even the basics of what we have here is if we now grab our little cogwheel here and we start spinning it, you can see that that is kind of doing the railroad thing where it's always aiming in that particular direction. That's cool. We could grab I want to just have this spin forever. So why don't we right click on H? I'm going to use the C4D field driver just because, you know, everybody watching might not have mine. So we're going to add that on. So we're driving this parameter with that. Now, unfortunately, I do want to use my timer because a timer is a really clean, easy way of changing those values. And then the built-in one is a little less intuitive. So that would kind of go on a bit of a contradiction there. But hey, this is just the spins. People could keyframe this if they want. I'm going to make the rocket timer. And now we're just going to say to have a cumulative value. And it's going to loop forever. So every 30 frames, it's going to be outputting some sort of value. And that value is going to keep looping. And now that just becomes whatever our max rotation is here. I don't know how much I want, so I'll type in 90. Hit play, and now you can see that, yes, that is rotating. And we could change the time, or I could say, hey, go twice as fast. And now that's going to be rotating more. Okay, now, here's where I'm not sure. And let's give it a save. Actually, no, that should be fine. Yeah, there's episode 10. Let's jump to episode 11, scene files. And as always, you get access to the scene files right after the live stream if you're supporting as a technician or as an engineer on Patreon. Let's see. Pen drawing mechanical rig. All right. Now, here's where it potentially gets tricky. If I duplicate the entire rig and then we scoot it over 30, these are both still aiming at that same thing, just an arbitrary kind of spot here. Now they're both aiming over there. They're both spinning. Now in the reference, they are offset. Actually, they're both spinning at probably different speeds. So maybe that's less important right now. But now you can see that we've got these two different arms, both spinning, each doing their own thing. Now, how do we get this? Because do we need some sort of like double constraint here? I think that we do need some sort of double constraint. But maybe we end up these aims weren't working, but I think I just thought of a way we can definitely do it. Now, we don't need to use joints to build a joint rig, but just the visual helps it make it very clear what's happening. So I might go to character, grab a joint, and now that's aiming forward. So let's just say, okay, that's going to make a secondary joint, and we're going to pull this up, let's say 30, and I'm going to make another copy of that, and I'm going to pull it, I think I'll maybe pull it over 30, pull that over exactly 30, drop that as a child. So now we get this shape. So now that we have this, here's where I think we can actually make the shape I need to. And I think this should work then. So we will go to rigging and we will make a IK. It's just a simple IK setup, right? I believe so. So we have to make an IK. And I'm going to say the end of the joint chain is just this one. The goal of the joint chain is going to be the second dot here. It's going to be the secondary pivot. So let's link that in. And boop, instantly you see it snaps there. And now we've got the secondary shape. Now what we could do is we need to add a pole, and that the pole is going to be where the elbow wants to aim. So, and that's just in general where the elbow wants to aim. So I will add that star back in, at least for a little while. Nothing should change. Actually, it did. Oh, I accidentally moved the star down. It's fine, move it up. So now you can see this is essentially two-dimensional again. And I will reroute these other wires on there, but check it out now. Now, if you just look at this little joint elbow, now we get that pivot. If we, let me pop back over to the reference here. Boop, and boop. So if we pop back over here, now you can imagine this as this little section right there. Now, we're going to be able to do all sorts of like recalibrating of these different components in order to make like different shapes. But let's continue. Yeah, different speeds, different rotations, different offsets. All of those are going to result in like a different final drawing, all of which is pretty cool. But let's continue. And how do I want to do this? Oh, first of all, this joint chain should go from this arm's pivot. So I'm going to 0 those. Ooh. Oh, that was the up vector. It should be on that pivot. Oop. Okay. So that's good. And it's spinning with that cogwheel. So now we're pivoting from the correct spots. Now we could, we can see typically I like kind of decoupling these from the rig, but just for speed sake, I'm going to drop this as a child of this joint chain. We're going to zero it out, and then we're going to I'm just going to keep doing a lot of eyeballing here. I'm going to stop being so precise with most of these numbers. So I'm going to make this arm longer until you can see that essentially it's pivoting from where we want, but importantly, it's now overshooting. And because this is now a child within the joint chain, if I hit play, you can now see that that is indeed still rotating properly. For just to get some variation here, because right now they're doing the exact same movement, I will grab one of our cogwheels here and I'll say that you're spinning at half the speed. So now you can see we get more of a like an oscillation going. Okay, so that's overshooting, exactly what I want to do. And let me see, I will type in a precise number here of 20. Just because I want to now drag this in as a child of the second joint, zero all that stuff out. I guess the rotation, I guess I'll drop it as a child of that one. That's fine. Yeah, that's rotating. And I guess that needs to rotate 90 degrees. Yeah, 90 degrees here. And then we're going to offset that up exactly 20. So now we've got this kind of scissor effect. So now you can see we got these two things that are overshooting, and we've got that little scissor shape. So now we essentially do the exact same rig again. So inside of this rectangle, we'll make a new null and scoot this to 20. And I'll make another copy of that null inside this one. And that one will also be 20. I'm going to spin this around. It's a negative 90. I'll say positive 90. So those are just matching. And then both those rectangles right now are 47 long, 20, let's say 40. Yeah, so those should visually be kind of pivoting from the correct spot now. Okay, so now, actually, I'm going to make them a little bit longer. Said I wasn't going to worry about the visual, but still having that null look like it's kind of centered there is nice. Okay, now what can we, is there anything we can cheat here? Because entirely outside of the context of this rig, maybe it doesn't need to be outside the context of that rig. Or maybe it's a good idea to be outside the context of the rig. I'm going to make a duplicate of this joint chain here. Several different ways we could do this. And we don't need these nulls, I don't think. And so what we want this to do is I want this to always pivot from that null right there. Now, we could make it a child in the hierarchy, but for fun, why don't we add a constraint tag? So I'm going to say constraint. Let's say transform. And I want to both match the position. Actually, that's all I want to do. I want to match the position. I'm not worried about the rotation of what? Of the null that we made. So that's this first null. So like that, drag this null in, and hopefully, okay, that was the other null. This null. Okay, so now it's on the correct null. And then the end goal, what is that going to do? So you see this calculates now, and this is operating at expression 0. If I select this, you see it's also calculating expression 0, but it comes after. So this happens first, and then this, which is important. And now I want this to aim at what? Well, I want it to aim at the other null, which I think is the first one. Jump that in. That's the pole, dragged in the wrong spot. The goal. There we go. So now you can see that that has now jumped over here. So we've now modified we've duplicated the rig and very easily shifted it to now be trying to follow wherever this is and then go wherever that one is. So let's shorten up these two joints because in the reference, the secondary thing is not, it's a little bit longer than this section. So let's try dropping this down to 10, which might be too short. Yeah, I think it's too short. So let's try 15. We're just eyeballing, and these are going to be all very imprecise. And I'm not sure, but yeah, it looks like our rectangles are still working correctly. These are still oriented correctly. But the length can probably drop down to something like 20, and the offset here should be 10 and 10. Nope, negative 10, because it is on the opposite direction. Okay, cool. And then I'll just make those both. Actually, yeah, the crossing over point is the important thing. So we can worry about that later. But anyway, with this is, as far as I know, we've built this all in order. It kind of naturally happened the way I was like placing things, but every one of these tags is calculating in the correct sequence, so there should be no like frame of lag. So if we hit play, now now you can see we get this scissor of this double scissor effect. So already that's pretty cool. And essentially, like, this is the rig now. So let's maybe, I'm gonna shrink these down a hair, and I'll set it just a little. And then we could make our pen. And honestly, these are both pivoting from the correct spot, which is wherever this joint currently is. So I will actually just hit Alt G as a way of getting a null in the correct spot. And now this should be the location of our pen. And this is coming along with that one for the ride. So yeah, this is where our pen goes. And the rotation of that doesn't even really matter. We hit play, and now our null's in the proper spot. So then we save it. And now we go into our asset browser, and we'll search for the word, new asset browser layout. Let's search just for the word pencil. Is there a pencil? Yeah, looks like we got a redshift pencil here. That's cool. And yeah, because we made it kind of real world scale, you can see that it seems pretty good. Rotate that to be positive 90. And we could just make it, we can make a child of the null. In this case, I might make another constraint tag on here. And I'm going to say constrain to, oh, that's the aiming one. I'll delete that, which was the, this one. That's the one that's snapping to an object. So I'm going to say snap to the position of the pen. Just so it's outside the hierarchy and not, because if you stack all the stuff directly in a hierarchy, then like in some ways it's organized, but then everything gets buried in the chain, in the chain, in the chain. You start losing the relationships. Where it's like, I don't have to go digging through that hierarchy to find my pen or my pencil, and here it is just living on the outside of it. So let's zero those out, and then we lost our rotation. There we go. We'll just do 90. Okay, interesting. So now we got this pencil. The pencil is on the end of the arm, and because we just linked its position to be where that null that we had was, if we hit play, now we see our lovely pen or pencil moving around, getting placed exactly where we want. Now, this star is still relevant, but it's kind of just giving us our broad orientation. If I were to grab this and I start moving it, and I'm only moving it on, I'm not moving it on Y, you can see that that's not changing anything. But just so you know, if I were to grab this and pull it over here, you see the whole thing's going to flip and break. So this is doing work for us. So we want to make sure it's far enough out that it's never going to like invert those two, which given this rig should be completely fine. Looks like one of our arms here got out of whack somehow. So if we go to filter and say don't show the joints, it looks like that's just an accidental copy somewhere. That's not doing anything. Okay, yeah, we've still got all the other components. So yeah, now we got these arms. So now almost everything, well, let's get to the super important part here, which is going to be in our pencil. Let's make a null inside of it, and I'm just eyeballing this. We will scoot this down to where the tip of the pencil is. Let's just call that one tip. And then all I have to do is make a MoGraph tracer object, drop that to the bottom just for order of operations purposes. And now anywhere that null goes is going to make a traced line. So with any luck, hit play, and there we go. Now we got this line getting drawn. Now let's give ourselves a whole bunch of frames and just let this thing go. And now you see that this looped very, very quickly. The shape of this immediately looped around, which is good that's making that loop. But this is all about like how fast these are moving and how far apart they are. So I think essentially what I'd love to do is get these essentially to be moved as far apart from each other as they can be. So, but keep in mind, it's got to be at their maximum distance. Which, you know, it would, even there, that's pretty good. So that's going pretty far. So now let's just see what pattern that makes. Again, it's going to loop quickly because of this is all about like how quickly they rotate. But look at that completely different shape that we just made. So as far as making, I'm not aiming to make the exact pattern that they made. A lot of what they have there seems like the two speeds are nearly identical. But here's the most important variable here is it's going to be how often their patterns intersect. Right now, 90 goes into 180 very quickly. Those ratios match each other very, very quickly. But if these ratios were more off from each other, or number, like if one of them was like a prime number, then one would never reach the other one. So in this particular case, we could get more like a more detail here if we change this pattern to be 60. Now 60 still goes into 180. So let's start this over again. And 60 goes into 180, is it 3 times? So now you see, now we're kind of making this weird Z looking shape. But then we can say, hey, let's do 30. So we're essentially doubling the number of patterns. So right now we got 3, but now it goes into it 6 times, I think. So now this is going to essentially wave back and forth 6 times. And then when those numbers match back up again, suddenly, let's see. Okay, there we go. And back again. So there's the loop of what this particular scribble is looking like. And it will just, again, perfectly travel those lines. And we can now see, yeah, you see this wheel is turning very slowly. Now, it looked like in the other one that maybe both of the wheels were turning a very similar speed. So they'd just be off from each other a little bit. So let's say that we do want to do this 180. And then if we did something like 160, there's still going to be, I don't know how many times they both have to loop until they meet the same number. But if we type in 160, I know that these will eventually overlap. And let's see what type of shape that gives us. I think it's definitely more similar to what the reference looked like. It's amazing how fast it moves sometimes. Oh yeah, that looks a lot more like the reference. So my instinct on that was pretty good. And there we go. We have now looped around, and now we got this kind of balloon-looking shape. Now, so many different variables here. If we were to change the length of these arms, if we were to change the length of these other arms, if those arms were to become different lengths in some way, if the distance between here is going to be important. The length of these is going to be super important. The radius of any of these gears would dramatically change what we're doing. Right now, because all the stuff is identical, it means the patterns get met very quickly. But just to further illustrate what I was talking about, let's type in a number that maybe, at some point I wouldn't be surprised if it repeats. But if I type in 133, it's going to take a lot of iterations between, you could multiply 133, and then you could also multiply 180 by each their own individual number, and eventually they meet the same number. And it would take that many number of multiplications before they finally met up again. So you can see here that we're getting a similar version of that balloon shape. And I'm curious if at some point they will meet. But yeah, that's evolving kind of nice. Yeah, you can see every one of these steps kind of like stepping back. It actually has to loop around quite a few times before we kind of get that, like the next swirl of that pattern, which is pretty cool. And this one's looking really neat, actually. I'm digging it. And it's also possible, and it looks like, yeah, okay, so it just looped around and it got really close. You can see that this one is maybe only 1 or 2 degrees off. So it got really close, but it didn't quite go all the way. So that's where we didn't get the perfect loop. And it's still continuing. It'll keep going. And I do think at some point these will match each other. But does everybody kind of follow the concept of what's going on there? Now, of course, any of these could become geometry, and we could extrude and whatnot. But like essentially the principles here, I don't, it looks like it is mechanically sound. So I'm not super worried about making these look like extruded bits of material. So I'd actually love to see if there's anywhere the chat would like to go from here. Hey, Andy, how's it going, man? Oh yeah, Phil says reminds him of a Strandbeest, which are very cool. And yeah, in a lot of ways, I mean, the principles are all here, like very simple mechanisms. So, yeah, and if we let this go long enough, you can see how these lines are getting a little bit thicker. I think eventually, yeah, we would loop eventually. It'd be fun to make different patterns and wiggle this around. What's funny is like the distance, it's only the distance between these two things that matters. If I were to grab one and kind of pull it up and go further that way, then all it would do was draw this exact same shape, but rotated and off to the side. So is there anywhere else, anybody, especially Tobias, since you asked the original question, is there any additional follow-up that we'd want to do on this one specifically before we move on to an unrelated question? Let's let's see. Oh, Thunder, make the tracer line eventually lift and float and extrude. Yeah, that's well, okay, no, I think I totally follow what you're getting at. Now, here's the tricky part is you say eventually lift and extrude. And that's trickier. It's still going. And I still think it hasn't quite repeated, but it's cool. It's making it look more like flannel now. Like a plaid pattern. Um, the tricky part here is it's pretty trivial to make a tracer offset. Let me just show you. If I were to grab this tracer, I could just physically move the tracer down and you'll see that the line's getting drawn and we've got this thing. But I could not make it eventually go down because essentially however I move this, everything moves that amount. So in order to do that, maybe there'd be some like crazier ways to do it. But what I'm thinking to make that work is we actually need to go into particles. We're gonna use them in a relatively simple way. But let's say that we're gonna make a basic emitter, and the basic emitter, I shouldn't have deleted that tag. Actually, yeah, it'll be quicker. I can hit undo. Oh wait, the tracer wasn't moving already. So yeah, this basic emitter is going to emit. It doesn't matter because I'm going to say 0, 0. And we're constantly emitting per frame 1 particle continuously. We can right click and add another rigging constraint, transform, position, yes, rotation, no, to wherever the tip of the pencil is moving. So that's been snapped there. Let's go to our properties and say speed 0. And, oh, it looks like they fixed that. That's good. Before the variation, yeah, before the variation would be activated by default, and it was really annoying. Anyway, now what we should be getting is it was kind of initialized to my GPU, and let's grab my particle. Okay, we'll just wait for the GPU to be fed the particle system. There we go. So now pull the particle group down. I will tell these to draw a little bit bigger for the stream. So now we see that we get this constant sequence of dots getting drawn. In theory, if this is emitting exactly 1 per frame, this is identical to what the tracer was doing for us. So now I can select our particle group and make I think we need the particle group. I will make a tracer and we will say connect all elements. And now if I could now visually hide those points, it looks identical. It's doing exactly what it was doing before. But now it's interconnecting a bunch of points instead of just storing internally where it was in a given position. What this means is now we can put all sorts of properties on these individual particles and make it do different things. So let's try and make I think just a simple, would it be a math? Maybe a data mapper? Yeah, let's try a data mapper. So I'll put a data mapper as a child, and I'm going to take the age, and we're going to remap the age to the Y position. And eventually these might run out, so I'm going to just give ourselves, I mean, how far do we want to go with this? Let's say about 1,000 frames. So over the course of 1,000 frames, it's going to move up a certain amount. I don't know how far I want to go, but let's say like 5 eventually up. Actually, no, that's way too much. It was actually kind of nice when it was very slow and drifty. Let's do 200. And then I'm going to grab this lovely spline, right click, say soft curves here. And now we're going to say this is where it takes a while for them to start drifting. We'll leave a little bit of curve there. So now when they're born, let's see. Yeah, so when they're born, they're going to be moving a bit slowly. So you know what we're going to do? I'm going to say that, yes, we want this, but I'm going to say it's going to take even more frames. Let's say like about 2,000 frames. And I'm going to scoot this over so that for the first chunk of its life, it's not actually moving at all. So let's do that. And I mean, right now we don't actually need to see the points because it's just the line that matters. So those don't move at all for like the first 20% of their life. And we need to remap this to some, I need to scoot around this slider. But yeah, there, now you see the line, that bit of line only just started moving, but that line is going to start drifting up very, very slowly. But over time, it's going to go up faster. So now you can see those lines slowly start drifting up. And then I'll save it. Thank you, Thunder. So now those are drifting upward, which is cool. And then you are also requesting that the lines get thicker. Now, there's two different ways of interpreting that. We could be saying that they're getting thicker based purely, it's like they're getting thicker from the ground, or they could be getting thicker like as the lines are both traveling upward, and either are essentially equally viable. I'm trying to think if there's a, I might just duplicate this entire rig because ultimately we want two different behaviors on two different sets of particles. So I'm going to copy and paste the entire rig, and let's say that this one will be whatever, different color. And we have a second tracer, but this one, let's say that we are not moving at all. So now I've got two tracers. I'm going to pull the second one first. So this one will be our tracer static. My caps lock is on. And this one's going to be moving. So I think this is as simple as lofting between them. So I'll make a loft, put those both in there. And let's see. Why is there data mapper? Oh, it was already getting mapped to an absolute position. So now it's already offset. So what we need to do, there's probably several ways we can do this, because right now we are just, we're data mapping. So this is as simple as, let me grab my, let's grab the tip of the pencil. I'll actually yank that out just for a second. And its height is at negative 7.7. So now if we grab the data mapper and say, your position is going to start at negative 7.7, and this one is also, but actually we do need to data map that one just so that they're doing it. So I'm going to data map to the same number on both so they don't actually move. So in theory, if I did that correctly, yeah, now we don't see anything because the lines are identical. So what I actually might do is actually make these a little bit different. So like honestly, not much. Let's do like 7.9. So 7.9 on one of the lines. Oh, did I? I think I might have done, I goofed. I modified the wrong value. That should go copy, paste. And then this is the one that I do want to data map, but going to negative 7.9 in both of them. So now one line is always a little bit further down than the other one, but it's not going to move. It's just down a little bit. And the other one will eventually move. So what that means is now I have this nice thin line. Okay, our loft, the loft is not, this has always been something I'm annoyed by the loft. So the loft, am I thinking? Don't want to do that. I want to blend between these two lines, but annoyingly, the loft does not adapt its it does not adapt its segments from the number of points it's being like it's consuming. It just has an absolute number. So you can see I have to like actually increase this number here in order to get like the segments along it. Where really I just want them to like connect directly to each other. Like that's what I want. So essentially what we're going to be forced to do is just like put a huge number of subdivisions in there. Or we could like potentially with Espresso or something, we could say like, oh, it should get bigger and bigger and bigger as it goes. Now let's see these, it does look like it lags a frame behind. That could be the particles and then the tracer, maybe it would render correctly. But now because of all those things, subdivisions, you can see it's going slower, but let's let it run a little bit. We might need to increase that amount. And we might need to change, is there interpolation going on these? No, it's linear, so that's fine. Now, eventually, with any luck, we've got these really thin lines. We can make those as thin as we want to. But eventually, yep, one of them starting to go. Now you can see that the oldest line is starting to slowly drift upward. So that now we're just getting varied thickness because we have effectively two identical lines. It's just one is now starting to move upward. can't help but think that there'd be a better way of doing this than what the loft is currently doing. But maybe not. Now, if these were like some sort of transparent, I think this would probably look way better. Let's think. I'll give that a save. And let's go into Redshift. We don't have to like render out the entire animation, but let's go in and make a material here. And it's going to get applied to the loft. The way this geometry is kind of tilting here, like the way that's going, like to my mind, these oh, actually they're just interconnecting, and that just means that if these particles are indeed emitting exactly one particle per frame, I don't see why these are kind of offsetting from each other. So it's just like the loft is being weird. Anyway, let's go and make a ramp and yank that out. Let's pipe that ramp immediately to the surface. Unfortunately, this is very frustrating, but Redshift does not preview ramps in the viewport. So I found myself like in the past, like rendering out, like having an image-based gradient so I can actually see it in the viewport. Okay, so it is mapped to the orientation I want to. Lignazio, that is not a bad idea. Lignazio has pointed out that maybe we can get this loft working better, or the concept that we're dealing with the loft better if we actually did it with a sweep. And it's kind of an obscure use case of the sweep. But if we grab the sweep and then we feed it a line, we're sweeping the line object. That's the first one's a profile. Let's aim it up on Y and let's make it, honestly, the length doesn't matter here. So let's say 0.1. So we get that line. And then we're going to put the second moving one in second. And we're going to say that that's now the rail spline. And we're going to say rail direction. We're using rail scale. That doesn't look like it's. Oh, there we go. It's aiming on X. Now, interestingly, even that is still twisting around a little bit, which I still don't know why those are offset. That makes me think that the particles are not like emitting every single frame or something. But now it is adaptive to our point count, which is an advantage. So that's just straight up better. So let's go and render that again. Now we might have changed orientation. Looks like we did. So now we move inside of our gradient and we'll say that this is a horizontal one. And yeah, now it's getting mapped horizontal. And essentially what I want to do is kind of make a glowy line. So maybe we'll have that drive the opacity. And we'll say no color, no reflection, but we'll do an emission of like what, 15? And let's give that a kind of a glowy green with a little bit of whiteness still in there. And the opacity is being driven by this. I think we need to invert it. And I made it so dang bright that I think we want to like really ramp this down. Yeah, something like that. How's our interpolation here? It's smooth interpolation, which is probably fine. So now you can see that we get this bright glowy line, and it's going to eventually just stretch. Potentially, there's alternatives we could do there. But now you can see that as our line stretches, this glowy line is going to go up. Starts out nice and super thin, and then eventually it's going to start scaling upward. So let's let the animation continue a little bit, and we'll see what it looks like. So in the viewport here, it's going to look a little bit like a mess because we're going to have more and more lines kind of crisscrossing each other as they reach particular ages. Let's see how that looks. Yeah, that looks pretty cool. I like it. Wow, yeah, that's cool. Good idea, Thunder. I guess that's going to be continuously trying to update. Let's just let those go for a little bit. We're totally losing that original shape, but this drifting is kind of fun. In theory, these we could also have like turbulences and winds and have these start drifting in different directions. You would start losing your shape very, very quickly, but now we should have a bunch of lines going. So yeah, depending on the angle, those are going to look one way or the other, but you get these, pretty nice kind of like shafts of light looking things going. It's pretty cool. Our white glow is there. We might want to like pull way back on that. Like this might be too much brightness overall, and because we know they're eventually going to layer. But yeah, that all works well. We just have this pencil doing this really, really neat pattern. Yeah, I dig it. Let's save it as another version. And then is there anywhere else we want to go with this one? Because that was from Thunder Godling. That was exactly the type of when I ask everybody if they want to see more from it, it's exactly that type of thing I'm looking for. Of like, oh, we made a cool concept, but we're in the world of 3D, we're in the world of motion graphics. Like, what's a way we can change it? How can we make it our own? How can we plus it and combine it with other systems to make something else that's cool? So, that opens up a lot of possibilities. I don't think I'm going to do it, but like even if you were to take these rigs, like imagine you take these two rigs, potentially it's like you could even have these lines like oscillating back and forth, like the entire gear could be moving back and forth on like some sort of rail. Or I was imagining taking this entire rig, making a duplicate of it, and rotating it 90 degrees. I'm not going to we're not going to make this, but imagine taking this entire rig, spinning it around here, and then we make these spinning at different directions, and we put a line, like maybe we make a line that's connected here, and then a line that's connected here. Maybe you could imagine them as rubber bands, or maybe we have another kind of linear rail here that would overshoot on this one. And now we have four different things that are all moving, and then the pencil would end up in between the two, and then that would create a more complex drawing that would only loop if once this number as multiplied by some number would match that and match that and match that, and then you'd finally get a loop, and all of those could combine to make something even crazier. Even along those lines, like this is spinning at a particular speed, but if we put that wheel onto another wheel, so it's like that's spinning, but then it's on a bigger wheel that is also spinning, then that same kind of multiplication would happen, where you'd have like all these like extra patterns happening. You could even imagine a little gear and motor at the end. So it's like on the end, this is also spinning on some other pattern. And it's only when all those frequencies match up with each other that you get the perfect loop. Yep. So yeah, I think that is that one. Checking. I'm going to jump over to YouTube and see if there's any questions, because it looks like I don't see any follow-ups on this one. So I think we'll just move on to something else. Let me see if there was an earlier question. Let's see. Magalbu is saying, is there a way of beveling a thicken object in a way I can apply a different material to each part? Oof. It's a fine question. But I've been having a lot of trouble with thicken that I don't remember having when it was new. And I don't know if something changed or if I just didn't bump into it given whatever configurations I was originally using it for. So you want to, let me read it because the specifics matter there. Is there a way of beveling a thicken object in a way I can apply a different material to each part? Okay, if you're still here, whoa. There's two different ways of thinking of thicken, because if we put thicken on a two-dimensional object, actually I can use a text for both of these. If we change, I'm gonna make it something beefier. Let's just set this to like Arial. And if I set the depth down to 0, I'm pretty sure that this is acting like just a loft. So If we put that into a thicken, I'm not going to give up. It's here somewhere. There it is. Yeah, if we put thicken on here, it's just going to kind of make it two-dimensionally thick. Now, now I think about it, maybe I've answered my own question. That is not what you're looking for. You're looking for it to be that we've got this text object and there's actually depth on it. And now we're going to add thickness to it. Now, I'm already anticipating some problems. You see, like all of these little subdivisions here. I think it could get confused on like areas of heavy subdivision. But let's just plow on through, see if we bump into some of the trouble that I've been having. So you can see here already we're seeing some of the troubles. We're getting all these like crisscrossing kind of like Boolean, or not Boolean, but non-planar polygons. Now, if we put this on advanced, everything should look way better. But there's going to be other problems, I think. Yeah, so here's some of the problems I was running into, and I just don't remember running into these problems before. If you see, we've got this inner section there, and as these other parts are getting thicker, that one's going backwards, and that it's sort of just messes everything up. That is doing that. So I'm just going to maybe not address that part of it. Maybe I'm missing something. And it's like, and we could, actually even that, like, see here when I modify this position, like, is this the way it used to work? Do you see how like this E is getting messed up? Like, I just don't remember having those problems when I was making my what's new video with Thicken, because I did a ton of stuff with text on it. So I guess we could cheat and just type out a couple of letters here. In fact, we might just delete out the E, just so it's like, all right, that's not part of the question, and I'm not sure what's going on there, and maybe I'm missing something. Maybe if somebody else can do a test on their own and tell me what if I just forgot some important detail, like why is that throwing me off so much? Anyway, these should have an inside and an outside with any luck. If we change our view mode to display NG, I can never remember that one. I do it too infrequently. So you can see there's an inside and an outside. Now, presumably, you want to do a bevel, a parametric bevel. Now, the thicken itself doesn't come with a bevel. You see, there isn't one here. So obviously, the bevel has to come after the fact. So I don't know for sure, but we're going to make a bevel. And let's put that after the thicken. And now you see that, yes, now everything has a bevel. But your question is it possible to now have a material? I'm assuming we can limit the question to, is there a way of texturing just that new bevel? Now, let's push this a little bit further to see if I can show you that problem. And maybe it'll do a good job, because Bevel tends to be pretty good. But if we actually, it's pushing it out. That's why it's being super compatible. But if this Bevel was constrained in some way, I think we might be getting something that would be pinching. But it's actually doing an excellent job right now of keeping it clean. So anyway, we've got a Bevel. Now, the fongs are getting a little bit messed up, but let's change this to area square weighted, which is going to make it look way better. And honestly, it just goes to like our thicknesses here. I think we just got really big bevels. So like, yeah, we can even kill off the Fong tag, cleaning that up, except for the smoothest areas. Anyway, is there a good way of texturing just those bevels? I've got something in mind. It's a little, it's not hacky. Well, I guess maybe you could think of it as hacky, but let's see if we can kind of do it. Will this work? And I might use, right now we're using a regular bevel, but there is the node-based bevel, which is actually called Chamfer for no good reason. So here's Chamfer. If I drag Chamfer in, this is now node-based. And if I change this to edge mode, you see it's pretty much identical. We just set this to be whatever amount we want. And there we go. Now we're pretty much we're pretty much matching. Now I'm using a node because the entire setup I'm going to do here, I think, is going to be dependent on nodes. And I'm not entirely sure it's going to work. But here's what I'm thinking. Will this work? I don't know. We're going to search for the word select. And there is a node called select. And this is going to select certain polygons. So right now I'm going to say select all polygons. So my active, it's invisible right now, but my active selection is saying Cinema, or the nodes, are acting as if I just said Control A and have selected all of my polygons. And then I'm going to search for the word store, and I'm going to say store selection. So this is now a node-based parametric way of doing the equivalent of saying store selection. So it's like I'm going to say, we are working from the selection string active. I don't think I actually have to type that in. I think if it's empty, it's working from active. And now I'm going to store it as a polygon selection. I'm going to say pre-bevel. So what I've done there is I've got now a selection tag, and it's got all of these selections. And then, let's make a material just to demonstrate. So we'll apply that and get rid of our shininess, and let's make it pink, salmon maybe. And I will say limit to the selection, and you'll see that everything is still selected because that, that selection is grabbing everything. I go type in the word even here, and now you see it's only actually selecting every other polygon end or n-gon. So we'll go back to all, and I selected all. So now here's where maybe the trick comes in, is if we chamfer, now this selection came before the chamfer, and now new polygons are there, but those polygons didn't exist when we stored that earlier selection. So you can see that those are effectively untextured. Now, the simplest step to actually complete what you were sort of requesting would be, we can, without adding anything else, let me make another material here and apply this. And if I just move this material before the first one, you can now see that I get the teal on the bevels and I get the salmon color on everything else. And that's because this is saying apply to everything, no restrictions, which means it goes everywhere. You see if I yank this off, it's going everywhere. And then I'm applying this, and that's saying, well, I have to limit to where the selection, what the selection stored, but that was stored before the chamfer, so it's limited to that. Now, if instead you don't want to do this kind of trick where I'm just placing it first, let's say you do uniquely need this bevel to have a bevel selection, I think we can also do that, which it's a little bit of invisible selection math. Let's do it. I will make a copy of the selection. So imagine I just made a new one. And this time it's saying, instead of saying select all, I could say actually reference this pre-bevel. So now this is just essentially identical to what I had. But what we can do is say all minus pre-bevel. And now my active selection, actually, can we do this straight from a store selection? Yeah, I think we can do it straight from a store selection. So essentially everything I just did, we don't need that step there. In fact, this store selection, we probably could simplify this and get rid of that and just type in all here. And yeah, the same thing. Okay, so we just eliminated some nodes because you can actually type in your selection directly. Anyway, I'll move this down. Now we still have that stored selection. So if we do some selection-based math, I can say select everything and then subtract the pre-bevel. So if I do that, now it's making a selection tag called pre-bevel, which is now overriding the old one. So instead, I'll just call this bevel. So now we've got a second selection tag, and there's right now a bug where if you make a tag, actually no, this is, yeah, if this makes a tag and then I rename it or change it in some way, it'll actually not delete the old one out, even though the old one's not doing anything anymore. Just so you know that it's a bug, it's there, it happens, but when you close the file and reopen it, they disappear. So don't use the ones that don't exist anymore. Like here's pre-bevel, but there is no such thing as pre-bevel, but I can't delete it either. Anyway, we've now got something called bevel. So I can delete out this other tag. These all propagate up to the top, but now in theory I should be able to grab my teal selection and say limit that only to the bevel directly. And now you see I was able to get that selection by doing a little bit of selection math. Other, and there's just a dozen ways to do everything. We could have done things like, used a select, restored the pre-bevel selection, and then inverted and then restored it. And that would be a thing we could do. It'd be slightly different. But anyway, I actually use this trick all the time for like when you actually can't store a particular step and you need that selection. I do this type of thing to pretty much be like, well, there's no way of storing the operation I'm doing, but I could store everything that came before it, invert it after the operation, and then get that as a remainder. So this is actually applicable in quite a few different places. I don't know if the original questioner is still here. Maybe we'll catch it in a replay. But is there any follow-ups to kind of this concept as we have it? We could do more selection math where in theory this thicken, we could also output selections from there. So we could maybe do some more selection math to say only the inner bevel or the outer bevel as like overlaid by some of these that we're outputting. I don't think there's a need to specifically go into those. Select Bevels with nodal capsules. You just make 2 materials, but then you wouldn't have the selections. Let's see, 301. We still got half the stream. So let's see. I saw some extra questions. I thought another question was coming in. Or Lignazio. Oh, okay. Related question. When I say bevel with the solid mode, I always get crosses around the corner where I cannot assign the proper material. Do you know a parametric way of fixing that? Okay, you might need to guide me through. You might need to guide me through some of the specifics of what you're talking about. But when I use a bevel in solid mode, straightforward enough. Let's grab this chamfer and say we are in solid mode. And now, interestingly, that broke the technique I was doing, which is interesting. Huh. I would have thought that that would work on this. Anyway, I always get crosses around the corners and cannot assign a proper material. Crosses in the corners. What do you mean? Are you talking about like this type of thing? And you cannot. You always get crosses around the corners and cannot assign the proper material. Yes, sorry. The specifics of your question, I'm just not on the same page, knowing what the scenario is. This is really weird because this is really close to working. Like on the X, you can see it's done a great job of all these outer ones, but this inner one, it is not. You know what that's implying to me is that the chamfer is not giving, is reordering the indexes of the polygons, which would kind of invalidate what I'm doing here. You want to assign a material on the front and a different one on the sides. Well, maybe you're getting exactly what I'm getting, which is like, oh, it's this technique is getting messed up. So it could be that the chamfer. What's the right way of saying this? You know, they hid it. It used to always be in the interface, but now, if we go to where's it hide? Structure. Here's a structure manager. If we if I just make a cube, make it editable, you can now see that in the structure, I'm seeing all the points that make this up, but we can change this to be in polygon mode. And now here's all the polygons. And you can see that this is polygon index 0, 1, 2, 3, 4. Now, if I were, actually here, maybe we can even do this as a literal test. Copy, new, paste. Okay, so here's our cube. It's been made editable. And you can see that if I select my first 6 polygons, it is selecting all 6 of the polygons that make this up. If we do I'm going to do a manual bevel. So let's search bevel, and we'll actually do it as a modeling command. I almost never do modeling commands. Actually, yeah. Bevel MS. Yeah, I knew that. Okay, bevel. So let's do a bevel in which I'm going to, these are doing polygon extrusions. Oh, maybe it depends on the mode. MS in edge mode. There we go. That's what I'm looking for. So now I've done that. Now, here's the question. If we go back to polygon mode, to see if I select the first 6 polygons, they're still the same indexes. It still is working perfectly. And all the subsequent geometry got added after the fact. You see now everything that comes after is the bevel. But if we undo and we go back to our edge bevel and I say solid extrusion and I drag, yep, that's what I thought. So look at this. Do you see they're not at the top of the list anymore? They are now, it looks like all the modifications kind of, actually, these almost look nonsensical. I'd almost call this a bug. Go and report this to Maxon that the indexes are all getting messed up. Because now our original polygons are not the same number. And that just means all the stored selections that we had they're getting messed up here. Now, having said that, is there a kind of hacky way that we could get around that? If we go back over here, I mean, it's nice to prove what my theory was there. So instead of my active selection still seemed to be maintained, but the stored selection got messed up. And that's actually probably an easy way that that could have been messed up without like Maxon even realizing it. So here's the new thought. Let's turn that off. Now we just got some text. It doesn't matter that it's in the thicken, but we can continue from here. Let's use that same select technique that we started out with. So I'm going to search for select. I'm going to say select all. So now I'm actively selecting all the polygons invisibly. And then I'm going to chamfer, solid chamfer, and I'm going to solid chamfer from active. So now, oh wait, that's from edges. So select edges. So now I'm select. No, I want to select all the polygons. Yeah, so I'm selecting all the polygons. And then I'm doing an edge chamfer from nothing, which is all, or maybe I have to say default because we're in edge mode. Okay, so we're back to doing that. So now in theory, I have an active selection that selected all those polygons. And then we're doing a edge chamfer, which is now pushing them in. But my active selection is still going to be the good faces, the faces that we actually wanted. So instead of storing it before the chamfer, what if we store it after the chamfer? So search for store. And now we will take it from our active selection and we will name it, I don't know, inner. So now we have a selection tag. It's propagated up. And now if we say, okay, let's limit this to inner. Nope, that got messed up too. I thought that would work. Because on the cube, you saw essentially here's a theory I had is like I've got all of my polygons selected right now, but I'm going to go to bevel ms on the edges, and now when I bevel those, a new bevel is created. But if I go back to polygon selection, you see how they're all still correctly selected because those were still active. Essentially, we just tried to do the parametric version of that, but it didn't do the same thing. What's funny is like how the C4D code got transferred directly into things like the node-based chamfer, because the same bug got transferred over into it as well. Yeah, tricky one, but I think that is a limit. Fill. Oh, a normal direction. Well, Rune is asking or saying it'd be cool to select something based on a normal direction, and there is another capsule that does that. So capsules do a lot. If we we'll do it from scratch. Let's search for, it's called facing. So here's a thing called select facing. So let's yank out the text here just so we're dealing directly with this geometry. Actually, it'd probably be a good idea to put that into a connect just to be sure that we're welding everything properly. So select facing, right now I can say, well, select everything that's Y facing and within 15 degrees of it. So, and there's even a store selection here. So we can just say Y plus, and in theory, I can say limit that to Y plus, and now everything that's facing upward is going to be selected. And you can just go into this and say increase the degrees, and now you can see I was able to actually select everything that was facing within 40 degrees of facing the top. You could say Y minus, and we get the polygons on the bottom, and we can, essentially you can type in anything, any angle here, and then you can indeed do exactly that. So, and then you can say custom, and then you get this like direction, so you would be able to type in like some like arbitrary like angles, in which case this Z and maybe some of those, are the only ones doing it. But totally works. And lots of fun modeling techniques you can do just by selecting things that are like the topmost polygon, etc. Yeah, interesting. We're getting into the weeds on those, but we did learn some information. I think we found a bug. And select facing, another cool capsule that we don't, I mean, maybe there's a select facing here. Do we have select facing? Maybe not. So there's an extra superpower for you there. Phil, question about a square polygon where each point is chamfered with a different size driven by fields, it kind of works with 4 different chamfer node modifiers and field drivers. Field drivers? How are field drivers? And it wasn't clonable. A square polygon where each point is chamfered, a different size, driven by fields. Field drivers. Okay, maybe I sort of follow. Okay, I think that the question is, we've got a single polygon here, and if we were to make a chamfer or a bevel, but let's start out with chamfer. Let's just stay in node world here. So we make a chamfer, and I drop it on there. We are chamfering the points, and now I can increase this. Now you see you get these corners cut off, which is, is a pretty cool technique. But these are all the same, and there's no random variable here. So I think the question is, how could we get these to have different variables? But even more so would be it surviving being in a cloner. And it seems like you said driven by different fields. Does a regular bevel have field options? No, there's no fields here. I wonder, because cloners do not get along with capsules very well, because every copy of them needs to be like a new iteration, to my knowledge. Just out of curiosity, is what you're describing, if I were to make a copy of this and make one of these sizes like way bigger, and then we say blend, first of all, does that even work in a context like this? Yeah, okay, so those are blending. So I was able to make as many of those as we want, and we can blend between them, from one shape, just because we are now modifying these parameters. Keep in mind, doing this type of technique with a chamfer might be very relatively slow. It's a simple enough scene that it's not going to act slow. Now, back to the original question, which is there a way to get each of them to be different? If we, there's no random, that would be too consistent. Like, essentially, we could make 4 different selections on 4 different points. So each point would be assigned its own chamfer, because we could limit the chamfer to a particular selection. In fact, these are, we could just type in 0. And now you see we only get chamfer on one corner, because 0 is the 0th index of a point. So it's the first point. So yeah, those all get chamfered. And you see it is blending. But then could we put and we could make this random? I mean, it would be random by randomizing the blend. But you would need, you would, I mean, I just really, really wish we had access to fields inside of all the nodal systems. They're like, fields just simply don't exist in that context, unfortunately. Random. No, I don't like that. Everything I think of is like, it's very uniform. And my assumption here is that you want like essentially total randomness is my assumption here, or like a field driven randomness. But that would also, total randomness could then be controlled. But because there's no variable to do that, it's like every chamfer just has to be what its value is. So you could start making a bunch of different chamfers. Even if they're limited, but yeah, there's no sort of nice cloner blending stuff going on for that. Yeah. And then, yeah, the field driver in theory could be driving a parameter inside of a cloner. So potentially be driving the radius inside of it. I mean, maybe would that work? Maybe I haven't used Maxon's field driver in that way. Mm, maybe at all. If I did, it's not since the beginning. So if I'm saying I'm driving that parameter and we're going up to about 200, so the minimum is 0, maximum is, let's say, 200, and it's driven by a field. If we make a linear field, don't clone the linear field, aim it along Z, make it way longer. That already doesn't look like it's doing anything. That should do something, right? Yeah, right now that's not even driving it at all. Maybe they're maybe their field driver doesn't see nodes, doesn't see nodal capsules. If that's the case, can we do this with a regular bevel? Just for curiosity. Bevel the points. Turn that off. Scoot that up. Say that I want to drive my offset. This will go between 1 and 100. That is... Am I doing something wrong? Why is that? I thought that worked. Like, okay, there it is on one object. But I thought this worked in the context of a cloner, that each one would be locally referencing that. Am I wrong? We're blending. Let's say iterate. Okay. Maybe it's because I was in blend mode, because now we don't want to be in blend mode, which also means, let me hit undo a few times. Actually, let me hit redo a few times. Select all, copy, just in case I want to come back to this. Undo a bunch of times. Get back to my chamfer. Turn that on and see if that works. Cloner, not blend mode. Okay, now that's doing something. So now, yeah, based on where this is externally referenced, we're getting that corner chamfered. And now we're saying just, yeah, we're saying that. And that tag is driving that one specifically. So is it possible to say we're also chamfering 0.1? Does that propagate through? It does seem like it, where these chamfers are getting added to the end of the list. So, and then put another chamfer and then limit it to 2. And make another chamfer and limit it to 3. Remember, we started at 0, so now every point has the potential to get affected. So now that can pass through, and you see they're modifying, but they're each individually getting modified. So if I were to select all of these, go to field, and add in a random field, yank that out of the cloner. Did it apply to all of them? Random, random, random. Yes, it did. It is random field. And they're all in the same. They're each getting sampled from the same location. If we say randomize sample positions, no, they're still each relative to themselves. So the only thing I can think is that we do need 4 randoms. So there's a random, there's a random, there's a random, there's a random. 1, 2, 3, 4. Okay, 4 randoms. And now they each get their own unique seed. So we'll grab those. Not that one. And that one. So now 4 different seeds driving 4 different chamfers, each one limited to their particular selection. And now total randomness. And now, I mean, they each have their, essentially they have their own random seed. So I can change everything else uniformly. So I could like increase my scale and get some sort of uniformity going there if I were so inclined. The scale actually doesn't super match. Actually, the scale would be if they're all matching each other. If we grab this cloner now, set this to grid mode, and how much space do we need? About 450. Do, 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 do. Do, 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 do. Okay, now we got a bunch of these. So yeah, if I were to grab this now, um, I don't know if it's possible to go too far. Yeah, it's going all the way up to 200. I don't imagine we want to go further than that. So right now, if we're really tiny, I would think we're getting almost pure randomness. Also, we might want to increase the contrast here. To do them all at the same time, we'll go into remapping, scroll down, curve, and we're just compensating for the noise. You see this curve. Something's kind of annoying is that this curve is not even. You see this one goes to like 2.6, and that one only goes to like minus 1.2 or something. So that's annoyed me for a little while now. But anyway, if we give this a little bit of an S curve, we're kind of compensating for, let me go further. Let's go do 8.4. We're essentially increasing the contrast of the noise in a soft way. Yeah, so more contrast here, more likely get bigger and smaller instead of being in that soupy gray area. But now, I don't know for sure, but if we increase our scale enough, we should start seeing uniformity. Not in, yeah, there we go. Immediately, you start seeing that uniformity, um, where it's not each corner is matching each other because each one is based on its own random seed. But you can see that looking at like the bottom corner here, where you see like a little bit of bottom corner, more, a little bit less, more, less. And the idea here is if these noises get large enough, and if I made this super duper huge, then almost everything would be identical. Yeah, look at that. Look at the pattern we're getting now. You can definitely feel any given corner has coherence with its equivalent corner in other places. So essentially, now we've got complete random, complete control randomly of every single corner here. So yeah, actually, I didn't think that there was going to be a parametric solution to this, but here it is. We did not make anything editable. We're actually using the Maxon field driver in a really fun way. The Rocket Lasso one can do a lot that the Maxon one can't, but the one great thing that Maxons can do that the Rocket Lasso one can't is that it works inside of a cloner. Ours does not work inside of a cloner, where it's referencing something external to it. So Phil, if you're still here, is this actually getting to the problem you were having? Oh, how did I? No, I accidentally named that one 11. Bevel per point. What's cool is this technique would also work on cubes. You'd have to have 8 of those for all 8 points of the cube. Oh yeah, and I was going to see if those could be pushed further. I know it's random, but if they get pushed too far, what happens? Yeah, if you push too far, you're going to start getting these inversions. So 200 might be the actual max. Yeah, 200 is eating up halfway. Anything more than that means it might overlap. Yeah, each one having their own random seed. And actually what's kind of cool is if we get rid of the random seed, now they're all identical. So now you can see that each shape is blending, but they're based on identical values. But these random fields are actually sampled from the local position of the field. So if I grab this field and I could start moving it, you can see that I'm now offsetting just one of them. So you can see now just one of those is getting animated because it's passing through a cloud of noise as I drag it to the right. So in theory, we could take all of these and like offset them from each other. So they are all technically different. But they could all now be very much related. And essentially, if I make this noise large enough, we'd start seeing uniformity again, like where there would be some very, very direct uniformity. Add some animation on there. Let's go faster. Yeah, lovely pseudo uniformity there. Add in different random seeds, and we get total randomness again. Or, well, total randomness would be if we just say randomize sample positions. So now everything is utterly unique. But yeah, I guess the solution is you need as many random fields as you are applying unique points. Evaluation mode. Yeah, actually, yeah, Phil, you might be right. We might be able to use a null for the sample position, like per one, and then maybe we would only need one random field. I guess as an educational exercise, let's do that. I'm going to delete out that. Let's also um, reset the default and drag that in. Luckily, it's nice that we can actually drag that into all of them at the same time. Isn't it annoying when there's like you select multiple of an object and it grays out and you can't do anything to it? Anyway, there's a random field, and you're saying, and if this is true, it just did not occur to me. We have a sampling location, so we could say override the sampling location and then feed in a null. So in theory, we could make 4 different nulls. We'd only need 3, but let's make 4. And let's do all of these. Override sampling location. First one, second one, second, third, fourth, fourth. So, yeah, all these nulls are in the same location. Turn off randomized sample positions. Okay, so now you see all of them are identical. They're all doing exactly the same thing, which is a cool look. But now if I grab this null and I offset it, yeah, now that's different. So yeah, here's a way of getting away with, we might, because it's such a large noise, I probably need this to, these to go like, quite far away. Or now we can just grab this singular noise. Oh yeah, this does not solve the problem because now they're all uniform again. Like they're not randomly sampled. I do not think. And if we reset that, are they identical? No. Yeah. So it's either pure randomness here, but the randomness is uniform. And then if we were to offset, wait, is it uniform? Yeah, it's uniform. All 4 are doing the same thing. If we shift that, then does it come back again? Yeah, so now they are randomly sampled. So yeah, okay, so that does seem like it's a potential alternative. We're just offsetting the position with nulls instead of the random field. So, a handy alternative. Super good to know. I mean, that's actually a really good thing to know for building like, super specific technical rigs. Now you're saying, oh I don't understand. You're saying you want to do it with a spherical fall off. So does that just mean they all bevel? A spherical fall off would be so dang close to it that you would think that you would want them to be uniformly sampled. Am I wrong about that? We'll go back to just object location, feed in a single spherical field. Does this make 4 or 1? Did it make 4 and apply it to all of them? Yes, it did. That's what I would want it to do. So now we make this larger, and now the bevels are happening based on the spherical fall off. They're all being sampled. They are all being sampled identically, like, so all the corners are getting applied. So like these 4 chamfers are essentially pointless. But excuse me, I'm going to undo to get these nulls back. Okay, now we got the nulls and we're sampling the nulls. If we yank those out, let's grab a spherical field and yoink it out, scale it up. And right now these nulls are all floating in space. So let's reset them to be all zeroed out. So now they're all right at the exact same 0 position. And now I think if we turn off the cloner, turn off all of these chamfers, if we move each null to its corresponding point, so let's turn on snapping, and I'll snap that to that corner, and then let's turn on that one, and that's this bottom corner. I'm glad I checked because I was going to guess wrong. That one snaps to that corner, and then this one snaps to that corner. This one snaps to the last one. Then those should now be they are getting ever so slightly individually sampled. No, they're sampled. No, that doesn't make sense. That doesn't make sense at all because they're always inside the spherical field. So yeah, that was totally off on that. Yeah, now I can kind of sample each corner, but it's not in their universal relative space. Um, yeah, there's that wouldn't work. Um, unless there's some override sampling location. Yeah, no, that's not. That wouldn't do it. Is that maybe what you're specifically referring to? But yeah, I don't think there's not much more to explore here. We're either sampling from their individual location or from this absolute world override. But the world override is not relative. Well, I don't think it'll work, but it would go to, can the nulls get cloned around and get sampled, which already in the viewport they're not. This is still referencing their original location. It's not, these are not smart enough to sample a location that's also getting cloned around. They're not never relinking to their local null. Um, that would be crazy. Let's see. Dean. Um, would an image in the shader effector give us a nice pattern with this chamfer cloner setup? I mean, yeah, we want to go back to the previous kind of working one. And then this is the null based one. So I think it's actually the first one that we want. Yeah, would an image do anything? I mean, I don't think an image, I mean, an image could drive it. I just don't think it would give you anything like super clean and coherent. Like, would it be artistically useful? I don't think it would be because let me think. But yeah, because essentially all you're doing is shrinking. For all purposes, you can think of it as we're just shrinking the pixel, but technically we're only kind of shrinking one corner of the pixel. So it's just making a particular corner smaller. So it's like if you could do like a black and white image where it's like these little, almost do it like a not moire pattern, like a stippling effect where it's like the little dots, like pointillism, where every dot is larger or smaller. So you literally only have black and white, but because the dots are larger and smaller, it would kind of imply a grayscale. So essentially, you could get that same grayscale effect, but artistically speaking, I don't think it would be any different than um than just scaling the overall object down. It's the exact same end result. We're just doing it with bevels. And then there wouldn't there to my eyes, there wouldn't really be much of a reason for the 4 individual bevels to be being operated on separately, because it's kind of like, well, if that particular pixel is a particular brightness, um like that would bevel in the corners or not. I mean, I guess it's like you could have 4 times the resolution because we're on 4 corners and each corner is kind of individually showing some percentage. But now we're getting so specific. But in theory, just because these are sampling in world space successfully, then you could sample the texture like in world space for all purposes or as projected on this as a grid. Um, yeah, I don't think it would help the look. Mm-mm-mm-mm. Yep, Andy, thanks. Pointing out that field drive does work with capsules, which we eventually figured out. Um, can you use I'm assuming you mean partition, to make floor planks with specific dimensions? Ooh. Okay, so totally new question. I've never tried to do that. That's a fine question. So the rocket lasso capsule called Partition. So you can search for Partition, and me and my brother Danny made this. You drop it on, you get all these cool subdivisions. Now I have, and I've even got an example scene file in the assets browser. We you can make really nice floor planks with this, like really easily. So the basics of it are really simple. All we have to do is change our cut orientation to be manual and then put them all in the same direction. and then we could like randomize this to whatever degree. So even here, we could say that they're going to be kind of even, and then make exactly as many of them as we want. And then just to finish the technique, if I would randomize my cuts a little bit here, so we get some bigger ones, we got some smaller ones, you make a second partition modifier, and this one, we flip the orientation to be the opposite direction. So now you see we get the long planks, and then we get these breaks in between them. And I could randomize the cuts even more here, and we can even make more cuts. And now you can see that we can get these random planks all chopped along. You get like a really nice random wooden floor. Now the question is, would there be a way of using this to get even dimensions? And I don't think there is really. The only, because your only option starts becoming, because you're saying specific dimensions. So like we'd get rid of all randomness, and then our cuts need to be even. So you see, if I go up one, it's perfectly in half. If I go up another one, that one was cut in half, but this one isn't. So every time we increase, we have to double the amount. So what you see, we go from 0 to 1. And then to get the next level of subdivision, you have to double it. So we go from 1 to 2. And then we have to go up 4. So 1, 2, 3, 4. And now you see it's even again. 1, 2, 3, 4, 5, 6, 7, 8. Now it's even again. Now we did build in the tool of double. So you can change your subdivision type to double. So now, in the same way I was just doubling, that's what this is doing. These are iterations of cutting. So that's one cut. This is 2 cuts, 3, and now you can see we can get those all subdivided. But these are not based on specific dimensions. These are just a ratio of the existing setup. And then, so essentially, I'm saying that's as far as you can go here is like these even subdivisions on it. So you'd have to do the math of like how many planks you have, and then you'd have to like remap your boards here, because I can make this any dimension now. But if you're gonna now take this and flip it, and that's a little dangerous, and then do the other orientation, and we start doing a cut, you now see that it's doing one cut straight across. I'm gonna do this again, but now we're now we're just subdividing a plane. If there's no randomness, then all of these just get lined up. As soon as I add in even just a little randomness, suddenly you're like, oh yeah, now that's something unique. But it's by definition, most of these properties are adding in things with randomness. So thinking of it in a non-random way seems not practical. Now, like this would be tedious and it wouldn't be the way I'd want to do it. The new bool works better, but if we were to say make a single plank, could we just throw this into a cloner and set it to hex or honeycomb? So we say honeycomb, put it on the correct orientation, and then this is eyeballing stuff. But it's like I could type in a very specific dimension into my plank, and then we just set our proper widths and stuff here. If I pull this in, now you see that essentially we're making a brick wall, but think of this as floor planks, and now these are very precise. So we make as many of those as we want. We fill up whatever space we need to, so we can get this giant floor going. These are very simple, clean polygons. So my assumption here would be we could probably get a pretty simple, standard. Probably get a pretty simple bool going on here. So let's say we have a square room. Just eyeball that. So I don't even know if we need to connect. Let's make a bool, and we'll say A. I guess it's intersect A intersect B. Didn't like that. Let's try putting the cloner into a connect. Don't weld. Doesn't like that. Without union subtract. I feel like that should be working. Let's try flipping the order. That's a shame. See, maybe, am I doing something wrong there? I don't feel like I'm doing something wrong here. These are regular instances, so they're not, they should be real. So can we not Boolean a 2-dimensional polygon from that? I thought we could. But nothing is returning anywhere. Now, out of curiosity, if I search for the word bool, you can find the legacy bool here. So here's the old one. So now I'll say A. Oh, it'd be subtract B. And look, it does return something. So yeah, the new bool does not do everything the old one used to do. And then A intersect B. So now we've got this precise tiled floor, and this bool should be pretty consistent because this is such simple, clean geometry. There's not really an opportunity for it to mess it up. So yeah, this would be the way I might approach like exact dimensions. Is Mater? I'm not understanding why is the UV tag different? It has like an arrow. Yeah, I'm sorry. I'm just not sure what you mean by that. But yeah, this Boolean works on a this legacy bool is working just by intersecting with that and just doing a simple honeycomb pattern. I don't know where to go besides that though. Let's see. Are there any more questions? We've got just about 20 minutes. Thunder had a question earlier that we can maybe go back to. Ismater, I don't know. You saying it has a UV tag with an arrow. What has a UV tag? I'm not even sure what we're referring to. Zach, sorry, earlier saying something about speeding up, like having more FPS or something. I'm not even sure what project we were on when you asked about it. Okay, well, I'm gonna until we see the partition. Okay, the partition itself. Yes, the partition itself does have some UV options. So make another partition. Partition modifier, subdivide. And then we have, we built in, where did we hide it? Yeah, our UV mapping. So under polygon orientation, we have UV mapping. So we can use the original UVs of the incoming polygons, or we could remap it to be per polygon. So yeah, so it's generating its own unique UVs here. Oh, why is it different? Oh, okay. Why is the tag different? The tag is different because this is a parametric UV tag. This is being generated live by this partition. Like essentially, it doesn't exist unless this partition is saying, "I have just made you. There you are." Every time we make a change, it's destroyed and rebuilt anew. And is that same bug happening there? Maybe when I switched those, it made a second tag. So those it's that same bug that the tags aren't gotten rid of that we talked about earlier, unless I save and reload. But yeah, these tags have this arrow because they're parametric. In the exact same way, I don't know that we have it anymore, but some of the earlier stuff, yeah, you see these also have the little tag. That just means these are being made by the node rather than it being user made, so it can be easily manipulated. If we, I think if we current state the object, so you kind of bake it out, you can now say I can delete the old one. And now here's the baked down version. The arrow is gone because this one is now available for the user to change. But it's kind of like, it's like when you use the field driver to drive a parameter or use Expresso to drive a parameter. Expresso has taken over that parameter. It's completely in control. So you couldn't then change it independently. Only the Expresso could do it from that point. Oh, so yeah, sorry. Hard to keep that super clear in my head. I guess I'll save the scene file. Simple plank floor. Scroll, 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 scroll. Okay, going way back in the chat where Thunder had a question saying, would like to see a simple visualization of two planets' magnetospheres interacting with each other. What are you talking about? So here is a magnetosphere. Okay, let me pull it up on the screen. So here is a article from NASA about the magnetospheres, and yeah, so presumably, I mean, that's cool looking. I mean, that almost looks like a C4D viewport. Um, because it's the default orange of splines when they're selected, or when you've got them highlighted. Um, like on the basic level, I understand what the magnets are doing here, or like what these lines are representing. The magnetic field that's around a planet, and some of them are getting distorted and or just very stretched. And then it seems like at a certain point they're intersecting this outer sphere and they just crop them out. Um, so mm, I'm trying to think of what I would do. I mean, a lot of these, maybe there's some sort of rhyme or reason to what's going on with the way they're individually moving. But as far as, oh man, give me a moment. I'm still sharing this screen. So let me double check if there's a tool that we made that I don't think has been shipped yet. Dang it, it's not out yet. We would totally use a new capsule, but we can't yet. So let me switch you on back over here. And I'm trying to think. I mean, catenary can kind of do a little bit of stuff that kind of looks like that. I'm so sad that the new tool's not there because man, that would do so much for us. Um, having said that, if we make an N side and I give it 124 subdivisions, I'm going to put that into a cloner. We're going to set that cloner to be radial. We're going to get the axis correct. So in this case, it would be that. And I guess we can change our N side is not allowed to parametrically be an oval. We could, the way I like doing a parametric scaling now is there's a node capsule called transform. And so it's called transform geometry. And if we drop that inside something, you get access to essentially an entire transform, like position, scale, and rotation. So now based on that, we have X, Y, Z. I'm not sure which one I want. So I'm just going to guess, not that one. Yes, this one. So now you can see I can scale that down. And this is happening essentially as a deformation. So now I've got oval shapes from an inside. So now we set our radius. So that's essentially like this is kind of making those. And then we can make a bunch of them. And looking at the reference, actually, I think the radius is actually a little bit more something like that, maybe. Actually, and they are very, maybe the oval even stretches the opposite direction, but we're capable of doing that. So we do something like this. Yeah, it's kind of like that. There's definitely a little bit more to it. But yeah, it's kind of getting the idea across. But um, deforming them is non-trivial. How would I want to do that? Because, well, I mean, it's a pain because a lot of what I want to do here is just not quite going to work the way I want it to. No, it's annoying. I might make an arc and spin the arc. Oh yeah, there's those new handles now. Look at all these lovely new handles we have on our spline. So we can change the radius. I can grab this and drag the arc around. That's really cool. Whee! That's really intuitive. So I think, that's okay. That wasn't intuitive. That kind of pops around. So I want the negative version. It looks like the widget doesn't allow you to drag negative values. Honestly, I'm even just going to eyeball it. Nope, stop doing that. Bad widget, bad. I'm doing this so that I do have an open spline for clarity. So now there's this little open gap there. And increase my radius. Yeah, so there's an open gap inside there. That's pretty much the only thing I just changed. And the reason I'm doing that is now I can throw this into a connect. Don't weld. And now let's make a electric spline modifier. So let's search for a electric spline modifier. My second favorite tool we made. Now the whole thing's electric, which of course is going to look kind of cool. Electric. But then let's say that we're going to change our noise. There's several different elements here that are going to be really important. But let's change our noise to a simple purlin noise. And now you see it gets a little more drifty and wavy. We're going to displace, like, or we're going to eventually displace a whole bunch. But I'm going to grab my noise frequency, and I never remember if I have to go up or down. It looks like we got to go down. So we're going, a smaller frequency means larger noises. Now we are seeing a pattern on here that's actually a bug inside of the electric spline modifier. Technically, because these should be totally randomized. You can see that it's a per segment seed, but there's something called like a hash node, and it can give you random that's not very random, so it's circumstantial. It's rare to see such a clear instance of the seed not actually applying, but it's like when we make such a very large noise frequency, this can happen. So again, kind of annoying, and I honestly, just because it's see here they're all uniform, but here they're pseudo uniform, and I don't want that. And unfortunately, I don't have a good way of stopping that. But anyway, the reason I opened the spline is now you can see it's fading. Like we're fading out so that they actually do latch back in where they're originally supposed to be. Now, in theory, I could put this directly into the arc. Now they're all identical, and then we could feed several of them in and then give them different seeds. So now there are two completely unrelated ones. And now there will be, actually, if we do it seed-wise, I should be able to say blend. And yeah, now they are all unique. Of course, you can see it's going all relatively slow. Everything's pretty large, though. So I can say don't resample. But yeah, still kind of slow. But anyway, now there's only two of them we have to worry about. And we are getting maximum random. And again, this goes to like blending inside of a cloner now means that we are making, 25 different arcs with 25 different electric spline modifiers, each one unique. And the connect is also slowing us down, which right now we don't need. So I'll turn that off. Now these are drifting. Each is doing their own thing. Depending on our noise frequency, I could potentially increase the noise frequency. So each one is getting like a little bit blobbier. And now we can start increasing our displacement significantly more, which those two things kind of fight each other. Maybe we want more uniformity if we're pushing out further. And now you get all these lines drifting out. And now it's a push and pull of like how far we want to. Yeah, that looks a little bit more like it. They're all moving a little bit quick, perhaps. So we can grab our animation speed, drop it down like 25, and now you see them all drifting like at different speeds, but they're all fairly uniform. They're all sort of, right now they're identical except for the different seeds. So they're all kind of at full power, all drifting around randomly just based on wherever that noise is intersecting them. Where I'd really want them sort of drifting in and out, which honestly the electric spline modifier by itself could not do. It's not designed to, it applies noise everywhere except for like this fade off here. So potentially we could remap the blend somehow, but this is sort of giving the effect, and then just based on how much displacement. We don't have a ton of time, and honestly, right now I'm not really thinking of too much in the way of like alternative solutions. Yeah, I mean, we can layer up multiple electric splines, but I don't think that would actually help us in this case. A bit tricky. I'm double checking the chat. Yeah, okay, no update in the chat. Yeah, Thunder, I'm not sure if you're still around. Yeah, I'm not quite sure how much further to go on that because it's such a kind of specific and technical thing we were seeing in the reference that, it's like they're probably using like real math and real like data for magnetic fields that it's passing through. Yeah. Yeah. Yeah, still looks kind of cool. But How would I? Yeah, I can't think of. I can't. I'm not kind of artistically inspired by any specific kind of movement or something I'd want to change based on what we're seeing here. Mm, 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 mm. Yeah, I don't think Thunder's around anymore. So I do think that we might actually just wrap this up now, just a couple minutes early. Actually, it's only like 4 minutes early, so that's all good. But yeah, I've got to get packing so I can fly in a couple of hours. Next week should not be affected. I'll be back in time to do the next live stream. Maybe we can go. Everybody go message Winbush and say, "Why aren't you on the stream?" Um, Actually, we just didn't even try and coordinate this particular week, so maybe he would have been available. Let's save this one as number 5. Again, you get access to these scene files if you are supporting on Patreon at the engineer tier. And everybody who is supporting at that level, thank you so much. It's really fun. I love reverse engineering files, so that might be a good way for other people to be learning. So that's what I'm always kind of hoping for those. Also, what is this? Magnetic planet field, sorta. That makes it sound more grand than it is. Um, there used to be a gap where I had not uploaded all the replays and the scene files of season 5. So somebody actually messaged me looking for them. So I actually went through and instead of it takes so long to make those posts. So instead of posting everyone as their own Patreon post, also I didn't want to spam Patreon with something that's 2 years old. Instead, I made one post of all the videos and one post of all of the scene files. So that should also now be available on Patreon. But I do believe that's going to wrap this one up. Thank you, everybody, for coming in and asking us some interesting questions. We did tackle some things that are not the typical things, like that the drawing pencil thing. That was really fun, and then the modification of like having the lines drift up was really fun. But I do believe that's going to wrap this one up. I just want to say a big thank you to everybody for coming and hanging out, asking questions, and supporting on Patreon. That's always appreciated. And for everybody who subscribes over on Twitch is also appreciated. But for now, I think that's going to wrap this one up. Thank you so much, everybody. Until next week. Bye bye.